Streaming is on.
Hi, everybody. Excuse me. We are here for the final section of our lessons today in science, and we are looking at water, something that in this country many of us take for granted, but in other countries, fresh, safe drinking water is scarce, and the people's lives have been affected because of that. In this country, we have pockets where our water is unsafe to drink. And the biggest thing that happened to reflect that was the Flint water situation a few years back, which the city of Flint, in looking to save costs, decided to switch from the city water, municipal water, to piping in water from the Flint River, which for 50 some years have been used by industry, including Ford and GM, um, used by the city to dump raw sewage, untreated sewage, and also pipe this water in through pipes that had very high levels of lead. So I don't know if you know about lead poisoning. It can cause permanent brain damage to unborn children, to babies, and to small children. It can also cause a multitude of health problems in adults. So they first gave people a limited supply of bottled water, and they were going to cut them off, and the people sued. They went to federal court, and so they are under federal order to replace those lead pipes and to make sure that people get clean, pure water. The problem was that the issue went on for so long, despite the people begging and pleading for a solution. And this is what is considered sometimes to be environmental racism, where if a group of people has less power due to their income, due to where they live, due to their racial background, they are less regarded by the government. And that's found with air pollution as well, water pollution, soil, dumping grounds. All of these things seem to be found in poor neighborhoods. So we do call that environmental. We do consider that to be an environmental injustice. So let's take a look at today and how we can reduce the impact of human activity on these systems because we don't have a way, we don't survive. That's all there is to it. So, first, I just wanted to show you this picture of the water in Flint. And these are the colors of the actual water coming out of people's faucets that they bathe in, that they drink. And the water had high levels of PB, which on the chart in Science of Elements is lead. I mean, hundreds of times greater than what is allowed to be considered safe. And this is, as you can see, these corroded old pipes. This is where the drinking water is coming through, and the rust and the lead residue. And they called the Flint water crisis ground zero because it was the worst that we'd seen. But there are other Flints all around the country. If you want to read more about the Flint water crisis, I've attached a little article there. But what we're going to look at in class is how we can go about cleaning up our groundwater. So we're looking at a CK12 lesson, and it explains the steps to clean a groundwater aquifer. So we start by asking if you would drink this glass of water. And it's cleaning water is not easy. Cleaning groundwater can be very difficult. And if you want to drink clean groundwater, it should not be polluted in the first place, or it should be cleaned. Groundwater pollution. Pollutants in the surface water can filter in the groundwater and enter a groundwater aquifer underneath underwater stream. Irrigation water can bring pesticides and other chemicals. That's from farmers. Water can seep into the landfill. Tanks of gasoline stored underground can leak. Cars just dumped onto land and abandoned can leak gasoline and get into the groundwater. Pollutants can be filtered out of water that travels through rock and soil that works as a natural filtering. And it's effective, but it doesn't get rid of all the pollutants. So the pollutants that enter an aquifer spread outward from the source and they spread in the direction that the water is moving. It's a lot easier and cheaper not to pollute the water, surface water, than it is to clean it. And that's even truer for groundwater. To clean groundwater, um, the water must be cleaned and the rock and soil it travels through must be cleaned. And then the toxic rock and soil has to be moved somewhere else. And this is expensive and can take years, and that isn't always possible to do it. So, to clean groundwater, we must first eliminate the source of the pollution. And an underground tank has to be pumped dry and then dug out of the ground. And then a factory must be required to stop releasing toxic chemicals. Farms must be more important about the chemicals they put on their fields. And then we have to look at the extent of the pollutant. We're going to test the water in wells. And sometimes they drill wells to test the water. And they learn how the water is flowing, how fast and in what direction. And then they look at the contaminants in the groundwater and then determine where the contaminant plume is going. And sometimes you can actually see it, it's a different color. So, what do we do? And here in the figure two, these are wells that are drilled to monitor groundwater pollution. I don't know if you've ever seen them. So, what we do is to try to create a barrier in the aquifer, and that isolates the contaminated groundwater from the rest of the aquifer. The contaminated groundwater must be treated, and this is called remediation. And so when you remediate, you're correcting a problem, going back. Remember, is to go back, remediation. And then the cheapest way is bioremediation. And that's one way of treating the water itself in the aquifer by putting microorganisms in there that are bioengineered. We manipulate their genes so that they will eat the pollutant. And then they are injected into the contaminated region and eat the pollutant. And that is bioremediation. And that's short for biological remediation. There's also something called chemical remediation, where we treat the water in the aquifer. Chemicals are pumped in, and then the chemical destroys the contaminant. And it's much more difficult and expensive to remove water from the aquifer and then treat it, where you would pump water to the surface and then clean it using chemical or biological methods, and then you re-inject it back into the aquifer. And the contaminated rock and soil then has to be dug up and destroy the pollutant, and you put it back into the ground. So that's extreme. That's most expensive, the chemical remediation. That's a trip, y'all. So to summarize, to clean groundwater, we remove the pollutant source, we monitor the pollutant, and we perform remediation. Scientists test the water in many wells to see where the contaminant is. And they do this to see, to tell where it is. And over time, they can tell which direction it's moving. And then also, finally, we can clean groundwater using bioremediation or chemical remediation. Bioremediation, bio means life, uses microorganisms, bacteria, or some kind of living life form to eat the pollutant. And then chemical remediation destroys the contaminant. And the question is, why does the contaminated rock or soil have to be cleaned? Because it will continue to add pollution, right? What are the two types of remediation that can take place in an aquifer? I think that's there in your summary. And why do scientists monitor the contaminants in an aquifer? If you want to explore further, you can look at this story about the Hanford site and contamination there. That's all we have. Just make sure that you understand these things, that bioremediation is where microorganisms are engineered their DNA information so that instead of what they normally would eat, they are made to consume a contaminant, and they're injected into a pollutant plume to eat up the toxins. With chemical remediation, the chemical that will react with the pollutant is pumped into the plume or the stream of the pollution to neutralize it, make it where it is not harmful. And that remediation means to correct a problem. That's all we have for this lesson. It's a pretty short lesson. Um, for greater understanding, you can choose this quiz here. As a matter of fact, I'm going to assign it to you, and please participate. It deepens your understanding, and that's all we have for today. I will see you tomorrow for social studies, and everyone be well.